Yeah, hello. Well, thank you for having me here at PyCon Estonia. As you said, the name of my talk, or the title of my talk, is Oxidizing MyPy, or why I decided to learn Rust and start using it with Python. Just before we begin, I know the theme of today's conference is about the future of Python. And I just wanted to say that this talk is not just a Rust talk, and I'm not just saying that the future of Python is Rust, quite the opposite, in fact. I want to talk about using Python with Rust, or using Rust with Python, and why I think that's a good thing for the future of Python generally. As a little bit about me, my background is in natural sciences. I studied at Cambridge, and I studied this little weed down at the bottom here, the Arabidopsis thaliana. I'm a plant scientist by training, and then my PhD was in Computational Geography. I've never studied computer science. I'm not a computer scientist. I actually ended up becoming a software engineer because I enjoy building things and solving problems more than I necessarily do analysing the genetics of weeds. Not that that's not a fun thing to do. I'm now based in central London, and just before we kick off talking about coding, if anyone's following the latest Brexit debacle, I'm sorry. I have absolutely no idea what's going on either. And I think it's a terrible shame. And I just want to actually put a shout out and say thank you to anyone who's come here from the whole of Estonia or the whole of Northern Europe and beyond. And especially say thank you to the organisers. I think that people coming together to talk about technology in the future really is something special. I'm sorry about the state of the UK at the moment, but hopefully things will improve. What do? I work for decisionLab. decisionLab is a mathematical modelling consultancy. We specialise in defence, infrastructure, intelligence, and various other different markets and public bodies. We do a lot of expertise, have expertise in machine learning, simulation, optimisation, but they're not my expertise. My expertise are actually in taking those models from our data scientists and our consultants and so on, and turning them into production code or into systems. So as an example of some of the recent projects that we do, we've used a machine learning algorithm to detect illegal gold mining in the Amazon rainforest, and we're currently working to deploy predictive maintenance models aboard Type 45 destroyers for the Royal Navy. So these are the kind of projects we do. And incidentally, if you are interested, we are hiring, so do get in touch. I think every company will say that. So. Now I should say as well, I'm not an expert in Rust. Yet. I mean, I'm ambitious, hopefully I'll carry on learning. And this isn't just a Rust talk. What I want to do today is to discuss typed Python, and specifically explain why typed Python got me into Rust, or how I became interested in Rust as a result of typed Python. I want to demonstrate to you quite how easy it is to use Rust in your Python code. I want to sort of talk about how that relates to the future of Python as well. Unfortunately, this isn't a 30-minute lecture on how to learn Rust. That's unfortunately is a bit of a bigger job to learn a new language than just attend a talk. But hopefully it can give you a flavour of what it's like and how you can use it in your code. So let's carry on and start talking about PEP. So this is PEP 484, so Python Enhancement Proposal, something that goes to the community to change the Python language. PEP 484 really is the PEP that kind of introduced type hinting, although it's type annotation, people call it the same thing, type hinting, type annotation. And it's based on several earlier PEPs, as well as 3107 and various other ones that I haven't mentioned here. And the main thing that it did was to introduce the typing module into Python. And this is kind of a response to lots of type checkers that exist that were checking doc strings and things at the time. And so this really became a formal part of the language in Python 3.5. And even since its introduction in Python 3.5, Guido has been very clear, and I think the community is still very clear, that typing in Python is optional. There are now like crazy libraries that you can use that enforce typing at runtime, but they slow down your code and they're really just for fun rather than for production. And the point of typing in Python is really about IDEs, linting, documentation, and so on and so forth, not enforcing a type at runtime. So to take a little look at how that looks inside of our code. So we might have a function here. Apologies if you use type annotations. If you do, that's great, but if you've not come across them before. So here I've defined a really simple function. It just literally adds two integers together. But I've annotated that definition line at the top there. So it says it takes an integer x, an integer y, and it returns an integer as its result. So you can see these type annotations here. And then you can just see how we would use that function in that assert statement. Now, I really, really like type annotations. There's a number of reasons for that. First off, a definition line becomes so much more informative to read, and you can almost kind of see the shape of your function just by looking at that definition line. I don't have to look at all the code. I can literally see, oh, okay, this will take these arguments in these forms, and it will return this other data structure. And I love it. It just makes things so much clearer. You don't have to guess things like, oh, is that underscore s at the end of that variable because it's meant to be a string, or is that just someone was trying to say it's a plural? You know, there's no guesswork like that. And this isn't just for human eyes as well. There are type checkers, and the kind of de facto one for Python is MyPy, although there are alternatives. And that kind of adds an extra logical layer to your code to kind of check how it works, and beyond just simple testing. And there are lots of automated tools as well that you can use, like Hypothesis, that take advantage of this. And there are also things like Strawberry, the new GraphQL language that rely on type annotations and so on. And so let's take another example. If we look at this particular piece of code, so if we were to run MyPy against this piece of code, it says, great, success, no issues found. Now, that's great. MyPy is very, very good at spotting when you're wrong. So when you've used type annotations incorrectly, MyPy will tell you. And if you start using MyPy on bigger code bases, you'll find out that you're wrong most of the time. And if you never get to see that success message the first time around, it will take you 15, 20 minutes sometimes to be able to make your code work. And so, to give an example of when that code wouldn't work, I've changed this function ever so slightly. You can see here this little .0 that I've added to the end of my number 10, so that's turned that 10 into a float. And if I run MyPy now, it will say, oh, you know, I expected this argument to be an integer, not a float, and it will flag that up as an error. And that might seem a little bit annoying at first, it is. It's very annoying sometimes. But actually what MyPy is telling you here is that you're using your code in a way that you haven't designed it to be used. And so if you want to use it in this way, you need to either refactor your code, or you need to call that function differently. And this is actually quite important. You might think it's trivial, oh, it's a float and an integer, who cares? But if you're, say, running an online shop where you might be working with different currencies and you're starting to multiply things or apply discounts and do divisions and so on, it doesn't really make sense to have 1.3 recurring euros and things like that. So actually it's important to define these behaviors from the outset. MyPy can also spot logical errors in your code. And so this isn't just float, integer, list, tuple, those kind of things. It can actually start to say, oh, you've used your code in a way that you really weren't expecting to, or this is probably an error. But that's only if you tell MyPy to do that. So, for example, here, I've created, if we stick with the shopping example, I've created a function that's going to place an order. And so it's not actually doing anything here, obviously. It's, you would call an API or put something into a database and so on. But say this is an early part of my project, I know that my user ID, my product ID, and my order ID are all going to be integers. And so I've just created some mock integers there to say, okay, is this sort of working, hacking together some code. And I've put this assert statement down here at the bottom. I'm hoping that people can kind of spot the error here. Yeah? Yeah, no? Yep, it's one person here. Exactly, yeah. So here we can see that actually the user ID should come before the product ID, whereas actually I've put product ID and then user ID. But in fact, my assert statement is going to be fine because basically it's just 1, 1, 1. But we know that the code doesn't work because it's got that error in it. And so how can we spot that? We can use MyPy to tell us that we've made that mistake. And so one of the best features I think about typed Python is you have this function here, new type, which allows you to define a logical type inside of your code. And so here I've created 3 new types, user ID, product ID, order ID. And so now when I write my function, I say I'm expecting a user ID followed by a product ID, and in return I'll give you an order ID. And so I've put my mock IDs in there, and I've typed them this time around, and I've put my assert statement in. But now if I run MyPy, it tells me, oh, actually it flags that error to me straight away. And so rather than that maybe being an error that I discover 2-3 weeks down the line when I've refactored it and I've started to call my API to actually order something from an external service or something, it actually just flags it up to me straight away like, Dom, you're wrong, stop. And you hear that quite a lot in our office. So, strict type hinting in Python really started to make me think a lot more carefully about my code. And I started making fewer assumptions about the data structures that I was kind of using, and I was being much more explicit about the data structures that I wanted in my code. And this is especially true for these sort of non-Python, so these are things that aren't necessarily Python types, that are sort of attribute or traits, if you want to call them that, of Python objects. So things like, you know, do I need this argument to be a list, or do I just need it to have a size? You know, do I need this to be a set, or can it actually just be any iterable at all? And the same things with like a collection, a sequence, a generator, a list, a mapping, and so on. So I wasn't just thinking about the Python implementation of every single type I was using. I was actually thinking more about the structure of my data and how that's going to fit into the code I want to write. And so I wasn't just, I wasn't thinking just about Python types, I was thinking about abstract data structures. And for the very first time in my life, abstract base classes started to make sense in my head. And I don't know if this is just something that worked for me, but it was really typed Python that meant that abstract base classes, these are the sort of from ABC import, whatever, they actually started to really mean something in the code that I was starting to write. And if you've ever read this book, Fluent Python by Lucien Romalo, and if you don't follow him on Twitter, I suggest that you follow him now. He's a very influential, very interesting person in the Python community. But there's a chapter all about typing and ABCs in this book, Fluent Python, and there's an essay called Waterfowl and ABCs. I remember reading this for the first time. It appealed to me as a natural scientist because he talks about taxonomy and classification in biology and how that applies to data structures in Python. So this move from simply phonetics, which is looking at maybe the properties of your data structure, or sort of what kind of what particular things can you observe on an animal, say, and moving more towards a mixture of cladistics and phonetics. So kind of not just relying on class inheritance to analyze your type, and not just relying on attributes, relying on a mixture of the two. And it's well worth a read if you can get it. I think you can actually get the essay itself online without buying the book. But obviously it's always good to buy a book. Don't start pirating on my account. So all of a sudden, all of the Python code that I was writing started to look very typed. And so it's a bit like when you maybe are coding in JavaScript and then you switch to TypeScript. Your code starts to feel very different, and it starts to feel much more kind of disciplined. But at the same time, I'm aware that one of the big advantages of Python is that, you know, it's not a typed language, you've got this dynamic typing and so on, and you don't have to manage memory. So I thought, if I'm going for the mental overhead of typing all of my code, maybe I could start using a systems language. Maybe that it's time to switch and to start thinking, well, maybe you know, if I'm happy and comfortable with a typed language, maybe I should use a typed language for some more of my code. But it's exactly so. I had to decide which language was I going to choose. And so I explored Python, I explored C++, and remember, I've never been a computer scientist. I didn't do the introduction to C course in my first year of university or something. And so I was kind of nervous, or I thought I need to make the right decision here if I'm going to learn a systems language. And managing memory was the biggest issue for me, and in particular, avoiding this thing, undefined behavior, which in the C standard is defined as basically weird stuff. So something that shouldn't be happening, but is happening, and that can cause all sorts of things, seg faults, or just security leaks, and all sorts of weird and wonderful things. One of the reasons why you have to patch your computer so often is because of undefined behavior. And you know, I'm forgetful at the best of times, and so the thought of managing my own memory just kind of scared me. In Python, we have this wonderful naming system, and so, for example, you can see up at the top line here, I'm defining two variables at the same time, A and B. They're both going to be equal to this value, which is just an empty list with 1 in it here. So what I'm saying is, okay, Python, create a list for me that's going to be a part of memory. And I want, whenever I use this name B, I want it to point to that part of memory. And then I say, I've also got this name A, and I want that name A to point to the value that B is pointing to. And so both A and B point to the same part of memory. So you can see the addresses here, the hexadecimal ones there, just both an address in memory on my laptop. But now if I delete one of those names or one of those references, so that's the first one there, B, because B is defined before A, you can see that actually A still points to the same place in memory, and it's still full, and it's still got the same value in it. One of the big problems that you can run into in a systems language is a dangling pointer. And so the idea here would be that if I deleted B, Python would also, or my language would also delete the value that B pointed to. A would still be pointing to that part of memory. So if I did something else in my program, and then later on accidentally put something into that part of memory again, and then I tried to use A, it could reveal something from my computer's memory that I didn't want to reveal to the user. So you can kind of think of this as like the computer equivalent of a Freudian slip. So it's where there's something in your kind of memory, or there's something in your particular head that you don't want to reveal to others, but you might accidentally do it. And I'm sure that no one can guess who this cartoon is based on. So there I found Rust. And Rust is a type-safe systems programming language. So that means that it avoids all of these issues with dangling pointers and memory management and so on. It's a compiled language, and Rust is actually compiled in Rust as well, so it's like turtles all the way down. It's not a wrapper around another language like C or C++, it's its own thing. It's developed by the Mozilla Foundation, and if you come across Armin Warnasche, the founder of Flask, he is now a major kind of evangelist for Rust and the language generally. It handles memory management, it garbage collects for us, and it offers us fearless, in their words, concurrency. So if something can be done concurrently or using parallelism in Rust, it will be. You don't have to tell it to do it. And it's got a very well-developed ecosystem, which is kind of great. And so just as a very basic hello world, you can see the syntax here is a little bit different. Braces are back, as are semicolons, and you can see that the function syntax is obviously very different to Python with that exclamation mark there, and there's lots of kind of subtleties to the syntax that obviously, if you want to learn Rust, you'll have to get familiar with. But Rust's compiler actually prevents you from making those kind of mistakes to do with memory. And so, for example, if we were to try and do the dangling pointer exception that we had in Python before, the equivalent of doing it in Rust would be this piece of code here. But even as soon as we try to compile that, well, first off, Rust complains because we've got an unused variable, which we need to flag up, and you might get like a flake cake would flag for you in Python. But then you can see as well that because we've borrowed, and this is kind of a Rust term here that takes a while to get used to, the idea of ownership, movement, and borrowing. But because we've borrowed that value later on, we can't use it in our program at the moment, and Rust will just throw a complete wobbly and tell you can't do this. So your code can't compile in an unsafe way. There is something called unsafe Rust, but I've never touched it because it just sounds like a bad idea. So you can see in the Rust documentation and in a lot of the literature, and especially the O'Reilly book, Programming Rust, which is a great kind of introduction to the language. There's lots of reflections on learning Rust. So you can see that it kind of forces you to learn good practice in a systems language at the very outset. You can't write unsafe or bad Rust because the compiler won't let you. It's not the kind of language you can necessarily learn in a couple of days and then sort of learn the hard stuff later on, like JavaScript might be, or like Python as well. You have to learn this kind of strict safety immediately, and it can feel uncomfortable. But I think this is a very cheesy line, but it does kind of ring true. This has led me towards feeling like compiling my code actually means something to me again. And that's Mitchell Nordine, that's quoted in the Rust documentation. I just rewrote all of my code in Rust, and thank you for having me. Although obviously I didn't. It's a little bit more complicated than that. And in fact, it was really just the beginning. To kind of give you an idea of some of the things that I've learned, the biggest one, the take-home message is this: Rust compiler is even more pedantic at telling you that you were wrong than MyPy is. And that's a good thing. It can be very frustrating, but it is also a good thing. Learning typed Python, in my experience, was quite challenging at first, and especially working on it in a large code base. But it certainly forced me to look at my code structure in a lot more detail. I knew when I started learning Rust that I wasn't going to be able to do a very large production project entirely in Rust straight away, because that would just be madness, and I couldn't persuade anyone in my company that that would be a good idea. But I thought, can I use a little bit of Rust to kind of boost performance in those edge cases where maybe there's something that we want that isn't very fast in Python that we want to make faster using Rust. So I came across PyOxide, so there are two libraries that allow you to use a little bit of Rust in Python, Rust CPython, and then this fork of Rust CPython, which is PyOxide, and it only runs in a nightly build. There's a couple of subtle differences between them. I like Rust PyOxide because I think it's a little bit easier to use, but Rust CPython is certainly a bit more stable. And if you're wondering why oxide and oxidation and so on and so forth, obviously rusting is an oxidation reaction of iron. So if you want to go back to your high school chemistry, then that's why everything in Rust is oxidized. So, and so a lot of the imagery uses like gears and the color brown and so on. And if you are learning Rust, you become a rustation, a bit like a crustacean. And so that's the name that's given to the community. And there is a very good community. I have to say, sadly, I don't know anything about the Rust community in Estonia, but there is an international community, and in fact in Europe there's a conference, Rustfest, in Barcelona this November. And the weather in Barcelona in November as well, which is quite pleasant, so if you want to join me, come on. So I thought, let's use PyOxide to create a Python function that was written in Rust. And this is remarkably simple. So the first function I thought would just, to demonstrate this, is a summing function. So you can see here, this is the Python version. It's going to take two integers, add them together, and then return the result as a string. And so here I'm taking two arguments from Python of one particular type, that's an integer, and then I'm giving it back as another Python type, a string, after having done some operations on it. And so I have to write that in Rust. There's a fair bit of code to take in here, but you can see, obviously at the top, you've kind of got the equivalent of your import statements in Python. And then I write this function inside of Rust, and you can see I've got this macro, that's the bit in green. And I put a doc string into that function as well, that's the comment in red. And then I literally just take two, this is unsized integers, and then return it as a string. And this OK syntax here, that's a little bit strange, and that's a Rust thing. It's to do with results and the way that Rust handles exceptions, but once you learn it, it's really quite powerful and quite useful. And then at the end as well, I just have to export this as a module, again using another macro from PyOxide, and I wrap it using another function and so on. So you have to compile it, obviously, because it's Rust, and then once you've compiled it, you get this file here, which is a lib pycon e rust.so. So I just copy that then into my directory that I'm using this function in Python. Obviously, if you're going to ship this as a package on pip and so on, you'll have to create wheels for lots of distributions, and there are lots of different Medium articles and tutorials and stuff about exactly how you can do that using continuous integration in like Travis or CircleCR or something. And so here we've got this SA file, and then literally I just import it in Python. So that's the name of my SA file from PyCon import some string, call the function, and it works. And it's really just as simple as that. I've created a function in Rust, I've done a little bit of compiling, and now I can use it in Python. And not just that, PyOxide also ensures it behaves like a regular Python function. So I've got my doc string here, and if I was to use something like inspect.getSignature, that would just return exactly like it would for an ordinary Python function as well. And so it just happens that this function is written in Rust. Now, that's cool, that's a very simple example, but what if I wanted to do something to actually give me a performance boost? And so again, I've done a very simple example here to make it kind of understandable in a short talk, but what I want to do is write a function that's going to count the number of double letters inside of a string. So here you can see I've got AA, BB, CB, EE, F. So there's 3 repeated letters here, A, B, and E. Now, Python isn't strong in doing string manipulation and string analysis. If someone wants to take issue with that, shoot me, but it's not. So what I thought I'd do here is a pure Python implementation, rather than using a regular expression, to look at how to count the number of repeated letters. So I'm using the zip function here, and then I'm literally just offsetting it by 1. So I've got every letter, so I've got a tuple now of every letter and the letter that comes after it. And obviously because zip will only zip to the shortest, it's not the itertool zip, it's just the standard zip that will zip the shortest combination of pairs. And so here I can count the number of repeated letters just by adding 1 every time I found 2 letters that are equal to one another. So I rewrote that function in Rust. And the syntax, whilst obviously there are braces and everything flying around, the syntax is actually remarkably similar. Ignore the Python variable there, that's more to do with more advanced functions where you need to access things like the GIL. But here I'm literally just, I've got that zip thing again, I'm offsetting them slightly, and it really is exactly the same code, just in a different flavour. And then I benchmarked it using PyTest. And you can see the results are quite something, really. It's like an average of 1.6 milliseconds to 46 milliseconds. So I should have worked this out before I started speaking, but I think that's about 20 odd times, right? And that's a really significant performance boost. So this is on a 1 million letter long string. And obviously you can imagine this is a kind of trivial example, but when you're doing something quite complicated or you've identified a part of your Python code that's taking a long time to run, if you can get those sort of 20 times speed improvements, say if you're running a particular line in your model or your code millions of times, that's going to save you a lot of time and it's going to make your code a lot more performant. And it's not like you have to be some kind of crazy computer science genius to do this. It's literally just learning a new language. The language keeps you safe. You're not going to expose all sorts of security flaws doing it. And it's really straightforward to do. So you can achieve these enormous performance boosts using Rust without that much effort. And so just to kind of bring the talk to a close, what does that mean for the future of Python? Because obviously I've said, here's this brilliant language that gives you all this amazing performance. It's not that hard to learn. It's open source, it's safe. So yeah, use it. Well, actually, one thing that I think is fair to say about Python is that it's very popular at the moment. And there are lots more people learning Python from all sorts of walks of life, backgrounds, and they're all learning it for different purposes. But I don't trust what this person's learning it for here. I'm really not convinced about that. The point is that even people who perhaps aren't technologists and their jobs don't revolve around data, perhaps they're like a management consultant or they work in some kind of commercial field of marketing. People are learning a bit of Python now and are using tools like Pandas and Jupyter to do data analysis where before they might have just used something like Microsoft Excel. And that's a really, really good thing. Our technology is being shared and being used by wider and wider groups of people. And I think the future of Python, or the role that I see Python fulfilling, is kind of like a glue language between not just lots of different systems and technologies and interfaces, but between people and lots of different technologies as well. And there is almost nothing that you can't do in Python. And Python will remain that kind of glue language that connects together all the different things from the web to data science to to microcontrollers with little robots and all sorts of other things that you can do weird and wonderful things with in Python. So as Python developers in the Python community, what do we want to do, or what should we do? And my feeling is that actually it might sound strange when Python's so popular, but we need to move away from just working with Python-specific implementations of our code and start thinking just about, oh, this is a Python list, this is a Python dictionary. And start thinking more abstractly, especially using these typings and these annotations. Start thinking about mapping, sequences, iterables, collections, that kind of thing. And that, I think, will actually encourage more users into Python at the same time. It simplifies concepts and it allows integrations between different languages and different software packages and third-party libraries and so on, to be done a lot more easily. And when the need arises, yes, we can put things into Rust for, say, performance boosts, or into other languages for other different purposes, or maybe interfacing with some legacy system like SAP or Salesforce, although I'm not sure people would describe Salesforce as a legacy system just yet. I would. And so when we start thinking about the future of Python, as I say, I see a lot more typing, a fair bit more Rust, and lots more users. And I really think that this more typing and a little bit more Rust and performance will really encourage more of those users to come through and really kind of build Python as a language for the next God knows how many years. So thank you very much. If you want to contact me, I'm on Twitter, and that's my email address.
Thank you so much, Dawn. That was very insightful. Can I have the questions? Okay, so we have a few. Let's start with the first one. Why not Golang, as it has first-class type support, instead of duct taping other solutions on top of Python?
Yeah, a fair question. I have explored Golang. I have played around a little bit. I think it's what I really like about it is the way that you can just write a Docker container that has like a little web service in that goes super quickly. I wasn't as keen on the language when I started learning it as I was on Rust, because I think that there are perhaps more similarities between the typing in Python and typing in Rust. You're right, maybe you could argue that this, Rust is simply duct taping a bit like you would with C. But actually I wanted to stay in Python, is the main thing. So I work for a mathematical modelling consultancy. We have a ton of people of different experiences who all work using Python. And it's like I said before, Python is that sort of glue language. So I don't want to be that person necessarily that goes off and codes only in Go because it's so much better. And then you have to talk through complicated microservices architectures. I like the fact that I can write a performant library and then give it to my colleagues, say, to do a particular task, and they can use that in Python. I see Python as that kind of glue, and there's a lot more momentum behind Python necessarily than Go, I would say. Certainly in my company, it might be different than other people's experiences.
Okay, great. Do you also use Rust for machine learning? What are the main Rust libraries for ML you recommend, any equivalent of scikit-learn?
I know that the kind of data science libraries and sort of scientific computing libraries for Rust are a lot more kind of nascent and not as mature as they are in Python, certainly. I'm actually not really a machine learning engineer. I played around, obviously, and sometimes when we have evenings with beer and stuff in decisionLab, I have a little play with machine learning, but actually my role is focused much more on taking those sorts of products and perhaps black boxing or turning our prediction machine learning services into a Docker container. And so whilst I'll write bits of code that improve bits of code using Rust for very specific operations or functions that might be rate limiting, I have to say I'm not really a machine learning expert, so I couldn't answer that question very well, I'm afraid.
Mm-hmm. Have you taken a look at NumPy? You get similar improvements if you can write your native code in plain Python.
No, but I am looking forward to Travis's talk at half 2, and I look forward to finding out more about NumPy. So, no, yeah, short answer.
Okay. How do the errors propagate between Rust and Python when using this?
So you can raise, so Rust has so that OK type, or that result type I mentioned before, that can either be there's various different incarnations of it, but essentially Rust has some or an error, or OK or an error are the two kind of results that it can return. And there are so all of the different kind of basic exceptions that exist inside of Python have equivalents inside of PyOxide and Rust in Python, so you can raise a particular exception in your code with an error message if you want to make it a library of that particular type. And I think that PyOxide has some default catch as well, but I'm testing my knowledge of the documentation there, so I'd have to check.
Great. Can the libraries made for Python be used for PyO3? So you're asking, so if you've got, say, a Python library, can you use it inside of PyOxide? No, unfortunately. PyOxide allows you, is a Rust library that allows you to create a Python library, so you couldn't necessarily use a Python library inside of a Rust library. But that being said, there is a very, very rich array of Rust libraries, and so if you look on crates.io, you will find a Rust library that will do most of the things that you want to do. And the actual Rust language itself has lots and lots of higher order operations inside of it, and its equivalent of iter-tools is brilliant. So you won't necessarily find that, oh damn, I need to use some specific Python function inside of my library, inside of Rust, because there will be an equivalent to that in the Rust library, or there'll be a code that you can use. And also, if you do need to use it, then it's dead easy to just sort of write one function that runs in Rust, gives you a result, run something else in Python, and then put it into a Rust function, and then go into another C Python function, and so on and so forth. But like I said, Python's that real glue language.
Okay. How do you keep your new type code easy to write when you always have to convert from basic types to new types?
I don't necessarily think it adds that much overhead in my experience. So I generally will have a few different, I call them types with an underscore, so I'll have like an underscore types.py file in most of my libraries. And so obviously then I have to import from a particular, I have to import from my types file and to cast everything into that. And I'm not, I wouldn't say that it's particularly kind of cumbersome, because you literally just, when you're say returning an ID or you're sort of providing an argument, you just have to say, oh, this is say like a user ID, and then brackets user.id or something. And the other type that I use a lot with Python is a named tuple. And I think that actually named tuples really come alive when you have types like this, because you can just, you actually have so much logic that you can put into your code. So I wouldn't say it becomes a manageable at all. And actually, I've often found it forces me to organize my code a little bit better, because I have to avoid, say, a circular dependency importing a type. So I really have to start thinking about the hierarchy and the structure of the code that I'm writing.
Okay, great. How do you manage the build process in this mixed environment?
Circle CI.
Okay.
Could you elaborate?
Yeah, so it can be a bit more complicated, yes, and you end up writing a lot of very long YAML files. And there are automation tools as well that allow you, say for example, if you have a private PyPy server, you can use Circle CI to build all the different wheels for your particular library and then put them into there. And then you will use your private PyPy server, and you have, say, you've written a library, you can import it and then put it on there. And you obviously can also put it to pip, but you couldn't do that with proprietary code, obviously. So.
Great. How does Rust compare in performance to Python? I think that was Python.
I have to admit, I've not actually really worked that much with Python. So when I was deciding which particular language I wanted to learn, I was aware that Python being a fork of C, I was kind of scared of the computer science magic to it. But sorry, I can't give you a direct performance comparison. I'm sure there are lots online. But essentially, Rust is as performant as C, C++. It's a very strong static type systems language, and it's comparable to C. So,
Can Rust recognize missing brackets in its own code?
Yes, the Rust compiler will tell you probably missed a bracket somewhere. In fact, actually, a feature of Rust is that the Rust compiler is meant to be so kind of detailed in the error messages that it provides that if, as a newbie to Rust, you come across an error from the Rust compiler and you can't figure out how to fix your code as a result of the error message that you've got, you're supposed to flag that as a bug on the Rust project because it should have a more informative error message. So yes, that Rust compiler really will help you. And those brackets, I began coding years and years ago in PHP and spent a lot of time trying to find brackets, but you don't have to do that in Rust.
Okay, are there any well-known web applications written in Rust?
So Rust does have a web server built into it, but you'll find actually that lots and lots of large companies and large web applications are using Rust, but they'll be using Rust for a small part of their code, or some kind of high-performance bit that needs to be done very quickly. So yes, there are lots of examples. You can find more online. My favourite one, because it was done by a friend of mine, is you don't have it in Estonia, unfortunately, but there's an app called Deliveroo, which is a bit like bulk food, and it's exactly like bulk food, but it doesn't have the taxi service attached to it. And so they obviously, it's a food ordering app, so they have a continuous stream of orders. So that's someone saying, I live here and I want food from this restaurant there now. And they have a continuous stream of riders who say, oh, I'm here and I'm available to deliver some food to someone if they want. So they have a matching algorithm that has to run in real time. to match riders with orders, essentially. So they can say, oh, this rider would go to this restaurant and then to this place to drop it off, and that would be the most efficient way of doing it. And so that was originally written in Ruby, and actually there's a talk online that you can find out more about this from Rust Fest, which is a conference in Florence earlier this year. From Rust Lab, a conference in Florence earlier this year. And so they originally had this algorithm written in Ruby, and then they decided to rewrite it in Rust, and got an enormous performance enhancement as a result. And although they wouldn't necessarily confirm, I think that there's a new feature in the app now, it's just kind of sad. I use this app quite a lot in our office when I'm staying late, where the rider will deliver more than one order at a time. And I think that they're actually able to do that because of the performance enhancement that they have in Rust, because they're able to optimize it much, much quicker. So yeah, there are lots of large companies, and my favorite one is Deliveroo.
Great. How can Rust be useful in analyzing large data sets for analytics?
Well, it really depends on your data set. So, for example, as we said before, Rust is very strong in, or comparatively to Python, in analysing large strings. It's very good at memory management and file opening as well. So, I mean, it depends on what your large data set is. If it's a very large graph, there's a Rust graph library. If it's a very large CSV file, there's CSV libraries. It really depends on your data set, but it will be useful because it's a very fast, very strong, very type-safe language. And so, yes, you can really use it in production. Cool.
That's great. Thank you so much. That was very insightful. Thank you for the great questions. Here's a little gift for you.
Thank you very much. Thank you.
Also from Paxful, I just quickly tell, it's a speaker and chocolates. So yeah, thank you so much.